Hello. In this video we'll be talking about how to use dimensional analysis in chemistry to convert and exchange between different units and different amounts. And this will be sort of your gateway into the concept of stoichiometry, which we'll address in a later video. And this is to get you into the idea of having to go from one unit to another. And this is some of the core mathematics of general chemistry, is going from one unit to another. And dimensional analysis is just a fancy way of saying converting from one unit to another to another to another until you get to your final answer. That's all dimensional analysis is, and you'll be using it throughout chemistry, general chemistry, organic chemistry, whatever chemistry you take. You'll probably be using some form of dimensional analysis. So it's really important to master this now, so it'll benefit you later when you have to do it. So at its core, as I said, dimensional analysis is just converting. And so, hypothetically, let's say you had a question like this. So, a piece of rope is 20 yards long. How long is it in meters? Now, I can tell you flat out you'll never see a question like this in actual chemistry. But a question like this is just to get you into the idea of how to start using conversions. And so I'll go ahead and give you the unit conversion here. 1 yard is equal to roughly 0.9144 meters. So there's your factor. And so you'll be dealing with conversion factors to a certain degree in chemistry. So if we wanted to use dimensional analysis to solve this problem, I will give you this big hint up front. Whenever you go to do dimensional analysis, always start with what you know. So start with what you're given and what you know completely. What we know completely is that we have 20 yards of rope. So we'll start with that. So we'll start with 20 yards. We want our final answer to be in meters. So to set up the dimensional analysis, you'll take a parenthesis and you'll make it a fraction. So on top, always put on top what you want your final answer to be, because we're going to multiply across and then divide by the bottom. Multiply the top, divide the bottom. So multiply the top, divide the bottom. I'm repeating that because I've had people get confused over the order that you do dimensional analysis in. Multiply everything through the top, multiply everything through the bottom, and then divide the top by the bottom. Because you can imagine this 20 is over 1. So you can just rewrite 20 as being 20 over 1. And since we want meters to be on top, because that's what we want our final answer to be, we will put 0.9144 meters on the top, and we'll put 1 yard well, 1 yard on the bottom. So you'll multiply through the top, multiply through the bottom, and then divide the top by the bottom, if that made sense. So I'll go ahead and give you a second to do that. And you should get your answer as 18.288. So I'll just round that up to 18.29 meters. So that's how many meters we have. So you'll notice that in dimensional analysis, here's a critical thing that you'll need to understand. Units cancel out. So see how we have yards up here and we have yards down here? These units cancel because one is on the top of the denominator and one is on the bottom of the denominator. If something is the same in the top and bottom, it cancels. So this is one of the fundamental things of dimensional analysis and later on stoichiometry. Units cancel. We wanted our final units to be in meters, and that's what we're left with, since that's what we wanted our final answer to be in. And remember, we put that on top, because we always put on top what we want our final answer to be in, as far as units go. So our final is units are meters, so we put the meters on top. The yards cancel. So hopefully that was pretty intuitive. But like I said, you won't really get a question like this in actual chemistry. But this is just to set you up to sort of think about how you can do conversions and dimensional analysis. Let's do one more. So a little more complicated one this time, because often your dimensional analysis will have many steps involved in it. So multiple different conversion factors. So we're given that a brick of iron weighs 33.4 ounces. What is the weight in kilograms? So some conversion factors of use. So 1 pound is equal to 16 ounces. And 1 pound is equal to roughly 0.454 kilograms. So we'll use this to convert, and so we'll take this one step at a time. So remember what I said. Always start with what you know, and what we know is 33.4 ounces. So that's where we'll start our dimensional analysis. So we've got 33.4 ounces out here. And we'll set up the first conversion. So the first conversion we'll use is going from ounces to pounds. So we'll go from ounces to pounds. So we'll have 1 pound up here is equal to 16 ounces. Remember, like I said, you can always, should probably move that ounces. You can always put this over 1 if it makes more sense to do that. And so you'll notice that ounces cancel. So no longer have to worry about ounces. Then we'll need to convert from pounds to kilograms. So pounds in this case was our middleman. So we'll put the kilograms on top. And the pounds on the bottom. And so now pounds cancel. So we're just left with kilograms. And like I said, multiply through the top and then divide by the bottom. So multiply through the top, multiply through the bottom, then divide the top by the bottom. So I'll give you a second to do that. So once you've done all of that, your final answer should be around 94.948. roughly. I rounded a little there, but there's our final answer. So notice how we were left with kilograms, and that's what our final answer is in. I can't really stress how important units are when you're doing dimensional analysis. I would make a habit of always writing your units and scratching them out as you cancel them. That way you can keep up with your units as you go through. So this is just a brief introduction into dimensional analysis and conversions. In the next video we'll talk about stoichiometry, molar mass, and how you can use that when you deal with a reaction.